Hey, Mr. J here. Wanted to talk about something in quadratics known as vertex form. Vertex form. And it's really useful for graphing, and it relates to something we did before called completing the square. And it also is a nice preview of a topic called transformations, which we'll be doing a lot, or you'll be doing a lot when you get to high school into Algebra 2. Excuse me. So let's first talk about something called a parent function. And that's like the basic form of an equation. It could be y equals 2x squared. It could be y equals 4x squared, where it's narrower and it's increasing faster. It could be negative 2x squared, where it flips over and it's going down. In this case, we'll just start at x squared. I hope you see that this is our basic parabola at 1, 1, and 2, 4, and 3, 9, and also the symmetry of that, negative 1, 1, negative 2, 4, negative 3, 9. And now what we're going to do is we're going to modify it a little bit. And so I can put in y equals x squared again. Now it's blue. But I want you to think about what happens if, say, I add plus 3. What will that graph look like? What will it do to this parabola? And you could do some test points. You could make a table. But I'll just tell you that it's going to shift it up 3. And instead of at 1, 1, now we're at 1, 4. Every point on this black parabola has moved up 3. And if you change this to an H, you can see how that slides it up and down. Go negative 2. All right, so that's one thing I wanted you to see. Let's go ahead and do something else now. I'll turn this off. What if I change it, the x value, before I square it? And we'll close the parentheses. So x minus 3, or we used 3 before. Let's do 5. Now this is a bit counterintuitive. You might think that this is going to shift it 5 to the left because it says minus here. But it doesn't. It's going to shift it 5 to the right. And a little more careful analysis will show you why. If you plug in a 5, what does it do? Well, 5 minus 5 gives us the 0 we're looking for. If you plug in a 6, 6 minus 5 gives us the 1. And there's the over 1 up 1. That's 6, 1. And 4 would give us negative 1. So the inside here has an opposite feeling. So if I make that the H and add the slider, if I keep this as a minus and I go left, it will go left. And if it goes right, it will go right. If this had been plus, then it gets funky and it would be the opposite direction of the way the slider goes. So really important that we think of that as a minus here. Now what we can do next, and let's go ahead and put in some other values and turn it off for a second. What if I do two things at once? What if I do plus 4 and minus 2? Can you make a prediction right now where you think this parabola will go? Thinking about the horizontal and vertical shifts. The plus 4, if you remember, that's on the inside of the parentheses, so that'll be opposite. That should take us over 4 for the vertex, and really all points, and then down 2. So now we're at 4, negative 2. So when you're given this form of a quadratic, you can instantly, hopefully instantly, find the vertex. The vertex will be the opposite of the inside value for the x, and it will be the outside value for the y. All right, if I give you one more, let's just try, how might I do minus 5 and plus 7. Can you think of where this vertex will be? Can you tell me that it's at 5, 7? Let's see. 5 and 7. And then it's at that 5, 7, then it's still over 1, up 1, over 2, up 4, over 3, up 9. So vertex form, very easy to graph. And I want to show you how to get to this funky form if given a standard form. So let's go over to a blank page here. All right, and let me make sure I put it on the screen for you. I created this quadratic, and we're going to graph it. Now, that's what we did on our quiz recently, is to graph this, and you can plug in points, say the y-intercept, right, at negative 5, right, That's a good first point. If x is 0, y is negative 5. Can we also find the axis of symmetry, which would be the negative 4 over 2 times 1, or 2. So that would put the axis of symmetry at 2. We can make that, say that, yeah, black's fine. Could we flip this point over across the axis of symmetry like that? Can we find the vertex? If we know it's on this axis of symmetry, we plug in the 2. And so that means our y value will equal 2 squared minus 4 times 2 minus 5. That's 4 minus 8 minus 5. That's negative 9. So we're at 2, negative 9. That's a useful thing. Hopefully that's going to agree with us. All right. And then the other thing, hopefully you would notice, let's clear this out for a sec. Could we find vertex, not vertex form, but factored form? I think I made one here that's factorable. So y equals, in parentheses, x minus 5 and x plus 1. And so that means our x-intercepts are at 5 and at negative 1. So we did find our vertex. Everything has some symmetry. I think I can even put a curve in here. Let's see how well this goes. All right, try to get the shape about right, and then maybe we can modify it if need be. Pretty good. It needs to be a little bit wider, I guess. I think I'm just about there. All right, so there's our parabola. Tough to draw parabola sometimes. Get it a little too wide now, huh? All right. But still, let's go back to vertex form. That's the real meat of the lesson here today. And so the way we do this, it's completing the square, which remember if we have squares, and I'll show you in a second. So what we're going to do is the y equals x squared minus 4x. And before we put blanks and it would be equal to 0 because we were solving, now I'm just going to put the blank here, move the minus 5 over, and then put another blank here. And I'll explain what that means in a second. But what we're going to do is look for the value here so that we can factor this part. We want to factor that part. And if you remember, completing the square means we would draw a square. And we'd have the x squared here. We split the minus 4x into minus 2x and minus 2x. And that means this is x and minus 2 and minus 2. So that makes this 4. So we do a plus 4 here. And before, do you remember we'd add 4 to the other side? Well, we don't have another side. It's y only over there. So instead of the other side, what we're going to do is we're going to subtract 4. Now we haven't changed the equation. We've added 4 and subtracted 4 on the same side. And what that means is it's y equals the factoring of this, which is x minus 2 quantity squared minus 9. Do you recognize this form now as the vertex form? The vertex being at 2, negative 9. Does that make sense? Do you see how that worked? So let's do one more example. Maybe one that's harder to graph. I think I can do this. Let's see. I'll just make one up. So y equals x squared, say minus 8x plus 11. It's not factorable. It'd be a lot of work maybe to find the vertex. We could, right? We could find the axis of symmetry and plug it back in. But let's do this vertex form. So y equals x squared minus 8x. Move the 11 over. Now we're looking for this value and the opposite of it, which is this divided by 2. Negative 8 divided by 2 is negative 4. And we're going to do plus 16. And we will do minus 16. Now can we factor this piece here? We get y equals x minus 4 quantity squared minus 5. Where's the vertex? It is at 4, negative 5. Pretty useful, okay? Because this one's not factorable. Let's take this for a second over to Desmos and take a look at it, okay? Desmos, back to Chrome for a second. All right, x squared minus 8x plus 11. I believe that was right. Let me just double check that. Minus 8x plus 11. And we'll turn the parent function off right now. So if we can find that vertex easily, all right, which we did by looking at, completing the square and finding vertex form, we were at 4, negative 5. Are we at 4, negative 5? And can we now graph that pretty quickly if we know where the vertex is? Over 1, up 1, right to there. Over 2, up 4. So you see there are answers to this, but they're not easy to find, right? We'd have to use quadratic formula or graphing. Isn't graphing a great way to find answers? All right, that's our lesson on vertex form.